A question about resilience in our water system in the state. Let me give you an analogy. In the space program, we build complex systems that we send across the solar system to environments that are extreme and poorly understood. The way we're usually successful is we build resilient systems. The definition of a resilient system is you build robustness in the design in the form of margins to handle worst-case scenarios, including just a bad day and persistent change in your environment. And I'm just curious, hearing what I've heard, do we know how much margin we need in the state's water system, given the uncertainty in future climate outcomes, given that in some cases we're seeing things outrun models? And I was also struck by what I think what both Peter and Ellen alluded to in the form of feedback, complicated feedback between impacts on water consumption and water availability, and how that ripples into energy systems, into agriculture, which can have feedback on the climate system. So I'm just curious, is anybody looking at how much resiliency we need, say in 2050, 2100? How much margin do we need? And how is that informed by uncertainty and climate projections and feedback? Thanks.
So that's a great question, and there's no great answer. Resilient means different things to different people for different kinds of systems. To some degree, one could argue we've built a resilient system. We've invested enormously in infrastructure in California precisely to deal with floods and droughts. So we have a lot of storage. We've gotten through 4 years of drought. Our economy is not going to suffer much in the general average sense as of this year, but it depends on how long the drought continues. And Ellen made the great point that our least resilient systems are ecosystems, which were sort of ignored when we built the infrastructure in the 20th century, and disadvantaged communities in rural areas and in our cities that are not the beneficiaries of some of the resilient components that we put together. In terms of future climate, there's going to be more uncertainty. There's going to be more pressure on water resources, even without population growth. And I think our system will show less resilience in the future, and we have to think about what we want to protect.
Good afternoon. Did you want to say something, sir?
I was just going to highlight something else that Ellen commented on, and that is, one of the things that we do to build resilience is this interconnection, is having increasing the breadth of our water portfolios, is actually having our systems interconnected so that a failure in one place can, under best conditions, be ameliorated by actions at other places.
Hi, I'm Bill Campbell. I'm with the Intertribal Council of Nevada. I'm the Tribal State Environmental Liaison. I work with the tribes of Nevada, and I work with the tribes on the eastern Sierra. And Ellen, I noticed you conveniently avoided talking about desalinization as a future for public policy. And you mentioned what a great job the Metropolitan Water is doing in preserving water, but you didn't mention the fact that they're pulling that water out of Owens Valley, and they're creating even more significant problems with Owens Valley than just the drought.
I only had 20 minutes, so forgive me for some of the detail that's there, but desalination is definitely part of the portfolio for some urban communities, and Peter and his colleagues have done some great work on this, looking at where it can especially make sense. It's still pretty expensive to do ocean water desalination. We also do brackish desalination, which is a lot cheaper in some places, but the Carlsbad plant is going to be coming online in San Diego, I think, this summer. Folks in Monterey are talking very seriously about desalination. In terms of the Owens Valley issue, it's exactly the kind of question about thinking about how to repurpose our water systems to also take into account environmental values. And there's been, that's a conversation in that ecosystem that's been going on for a while, and it's probably not over. But I can tell you that the LA Aqueduct had a lot less water in it this year than it normally does. So.
What is Owens Valley?
Yeah.
Thanks to all the speakers for very interesting talks. I'm Amber Kerr from UC Davis, and I have a question especially for Professor Diffenbaugh, but maybe for anyone who wants to take a stab at it. Several of you mentioned the co-occurrence of low precipitation years and warm years as a particular risk for drought in California. But of course, it's not a one-way relationship, because when precipitation is low, latent heat transfer from the land surface is reduced, and therefore, all other things equal, you would expect a low precipitation year to be somewhat warmer than average. In the current drought, where low precipitation and high temperatures, record high temperatures, have co-occurred, to what extent can the high temperatures actually be explained by the lack of precipitation as opposed to just being coincidental co-occurrences?
Yes, so certainly there are areas in the mid-latitudes, particularly in continental interiors, where we see really strong coupling between the land surface and the atmosphere. So in the Midwest, where I used to live, you could pretty much predict summer temperature from summer soil moisture and precipitation, and the coupling between them. I think there are some interesting questions out there right now for California along the lines of what you've described. The one you just laid out. There's also just with this ridging and lack of storms, you're basically getting a lot of high pressure, more shortwave radiation, solar radiation. So just the presence of the ridge and the warm ocean temperature should also contribute to warming. So there's another possible coupling. And then actually kind of buried in the conclusion section of this Williams et al. Paper that just came out, it's been mentioned a couple times, they have a hypothesis about irrigation. And, taking water out of the ground, putting it on the surface is going to create the kind of latent cooling that you're talking about. And one of their hypotheses is that with the reduction in irrigation during the drought, that's potential positive feedback towards warmer temperatures in the Central Valley.
If I could add a quick comment on that. The mechanism that you described is an accurate one. That does happen. But if you look at the precipitation data going back 120 years, we've had years as dry as this year, or individual years as dry, where we don't see the same temperature effect. So I suspect that there's probably some local effects in the Central Valley, especially the coincidence between lack of soil moisture, lack of latent heat transfer, and locally higher temperatures. But the statewide higher temperatures, I think, are very clearly parallel to the global increases in temperature we've seen because of climate change.
And I just have to comment also. You sort of phrased that towards the end of your question, just in terms of how much is the extra warmth due to lack of precipitation. I think one of the things you need to bear in mind is that ridiculously persistent ridge, it isn't just diverting storms away from us. It's diverting winds in from southwesterly, southern directions that are actually the reason why we've been so warm, why Alaska's been so warm, and why the East Coast ultimately, as it bends back towards the equator, has been so cool. And so it's not just, lack of precipitation drives warming, but the same thing that's giving us lack of precipitation is giving us at least part of this warming.
I think we have time for 2 more questions.
Fortunately, they're just 2 of us. My name is Lori Wayburn. I'm with the Pacific Forest Trust. And I had a question. I wondered if you would comment about the value of investing in natural infrastructure as well as built infrastructure. California is so dependent upon its Tier 1 watersheds that feed the Sacramento. And that is one area of the state that does appear to remain cooler and wetter with all the global climate change models. And in your discussions about what we need to do, none of you really talked about any emphasis on key watershed management. I was wondering if you might take a minute to do that, given the extraordinary dependence we have upon the Sacramento River and its key tributaries.
I'll start, and just because it's very much related to what I talked about with respect to what's going on with forests right now. The upper watershed management issue has been gaining attention and getting some good research done on just all of the wide range of benefits of
basically getting those forests back into a state of health, thinning them out. And just a century of trying to put out fires every time they start to burn has meant that our forests are way too dense and unhealthy, and therefore there's a risk that when they do burn now, they burn so hot and so big that you can have permanent loss of conifer forest ecosystems even, which is why CAL FIRE is just kind of working to keep them from getting too big and too hot right now. The Rim Fire is an example of that kind of big hot thing that they're trying to avoid. Everybody, I think, recognizes that the prudent longer-term strategy for building resilience back is doing serious upper watershed management, which involves clearing, selective clearing, it involves controlled burns, and thinking strategically about how to manage to get these forests back to health, which will have water quality benefits as well as some water supply benefits in addition to reducing the risk of catastrophic wildfires. But that's not something we can solve right now during this drought. During this drought, it's emergency management.
So it's a climate change issue, not just a one-year issue.
Yeah, exactly.
So I agree with that completely. Just to add, related to that is not just forestry and upper Sierra management, but it's going to be foothill management and groundwater management. If we can figure out how to spread more water in wet years and restore some of the groundwater overdraft that Ellen and I both talked about and people know about here, that's going to be a key component, and it's going to require a different kind of land management than we've had. And the final comment I would make is that, and you made it in your question, we're not paying enough attention to this. The money in the bond for water was not adequately focused on the upper Sierra regions and on forestry management and the role that might play in water systems moving forward. I think it's been a blind spot, and I think we need to get better at it.
Maybe just to add one last thing, over half of our forests are owned by the feds, and so they have to be key partners on this. And one of the challenges that some researchers at Berkeley have recently highlighted is that about 3/4 of federal owned forest lands in California are pretty much off limits to the kind of management that folks are looking at. So there's going to need to be institutional change as well as funding changes. Right now, when the feds fight fires, they take the money out of the funds that are supposed to be improving forest management, and that doesn't get replaced. So there's some fixes there.
Hi. Chad Moore with the Bureau of Reclamation San Joaquin River Restoration Program. So California's often been able to eke by in drought because we often have asynchronicity between Northern California and Central California. Central California has good snowpack in the high Sierras. We don't have to send as much water down the Delta-Mendota Canal if, say, Shasta is a drier reservoir. This year has been difficult in the sense that we've had both those extreme drought in Northern California and in Central California. And thinking about atmospheric rivers and the slides we've seen today, do we have any sense of the global climate models and their predictions in terms of synchronous Northern California and Central California droughts, which would have a compounding sort of impact of the more severity of drought?
Yeah, I can't be very specific about that, the sort of asynchrony between Sacramento and San Joaquin watersheds, essentially, and atmospheric rivers reaching them. But I will note that so like so many things, Northern California sits right on a cusp. Just as with El Niños and what direction the precipitation will go in climate models, that sort of thing. It sits on one of those cusps for atmospheric rivers also. And the cusp I'm talking about, and I sort of flashed it up there in that slide that had all sorts of things about future atmospheric rivers, is that right now, at least in the models that I look at, there's a tendency for the numbers of ARs to increase more to the south, say, of probably about the latitude of San Francisco. And the intensity of the atmospheric rivers that do make landfall to increase more to the north of that line. It's not, as I said several times, it's not a huge, but it would make a heck of a difference in a year like this. And so, unfortunately, in the projections that I'm seeing, Northern California is sitting on a place where it could go either way just because it's sort of caught, it's never right in the middle of one of these geographic patterns of change. It always seems to be pinched in between two of them. So that tells you almost nothing other than we're looking, but there isn't a good answer yet.
Thanks.
And with that, please join me in thanking our panel.